Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 1st, 2025, just 2 days ago. It introduces a new framework for generating interactive, lifelike virtual characters that can react in real time at over 30 frames per second. The paper is titled ARIG, Autoregressive Interactive Head Generation for Real-Time Conversations. Now, autoregressive here means the model generates each new frame of motion based on the previous ones, which is key for its real-time speed. The authors use this to understand conversational states like interruptions and pauses, creating much more natural-looking motion. Alright, so this first figure really helps visualize the core innovation here. It lays out the evolution of these models. You see, previous methods either used separate models for speaking and listening, or they processed entire clips of conversation at once. This clip-wise approach, as they call it, introduces a noticeable delay because the model has to wait for future information before it can generate a reaction. In contrast, the new approach shown at the bottom is frame-wise. It generates motion one frame at a time, based only on what's already happened, which completely eliminates that lag. Building on that frame-wise approach, this diagram shows us the architecture. It has three main parts. First, the Interactive Behavior Understanding Module, or IBU, looks at the history of the conversation, both audio and motion from both people, to understand the interaction's context. Next, the Conversational State Understanding Module, or CSU, uses that context to figure out what's happening, like an interruption or a pause. Finally, the Progressive Motion Prediction Module uses that state to generate the next frame of facial motion using a diffusion technique for smooth, realistic movement. Moving to the results. This table shows how their model, listed as ours, stacks up against other methods on a talking head generation task. They're measuring a few things here. First, sync score and CSIM, which check how well the lip movements match the audio. Higher is better for those. Then there's FID, or Fréchet Inception Distance, which measures how realistic the video looks, and for that one, a lower score is better. As you can see, their model scores the best in these key areas, achieving the most realistic video and the tightest audio synchronization. Okay, so this next table dives deeper, comparing performance on an interactive conversation dataset called Real Talk. We see their model again listed as ours, compared against a baseline and the ground truth, which is the real video. Besides the sync and realism scores we saw before, this also looks at motion diversity, basically how varied and natural the expressions are. Their model is again the clear winner, getting much closer to the ground truth scores. The bottom part shows that if you remove key components, like understanding the long-range context, performance drops, proving each part is essential. But beyond just the quantitative metrics, the authors also ran a user study. This table shows those results, where people rated their model against another method on several qualities, like overall naturalness, user-agent coordination, motion diversity, and lip synchronization. And it's really no contest. Their model, shown as ours, received dramatically higher scores across the board. This subjective feedback confirms what the numbers suggested, that the model's reactions aren't just technically accurate, but they feel much more natural and believable to a human observer. So to wrap things up, the key innovation here is a new framework for generating truly interactive virtual agents. It's autoregressive, meaning it generates motion one frame at a time based on what just happened, which makes it fast enough for real-time conversations. But more importantly, it deeply understands the conversational context, things like interruptions or pauses, to create reactions that are not just realistic, but also socially appropriate. The results, both in numbers and human feedback, are quite compelling. That's all for this week's AI Research Roundup. Thanks for tuning in.